Diffusion. Diffusion is the gradual movement of particles from an area of high concentration to an area of low concentration. It is just the natural tendency for stuff to spread out. Particles can diffuse through liquids or gases. An example for diffusion of a solid through a liquid is the diffusion of potassium manganate through water. Potassium manganate is a solid which is purple in color, and you can demonstrate diffusion if you add some of the potassium manganate into water. At the beginning, the solid will be attached to each other at the bottom of the beaker, as we can see, and then the particles of potassium manganate will start to spread out slowly from the area of high concentration into the liquid, which is an area of low concentration of potassium manganate. With time, the more particles will diffuse from the solid into the liquid, and then eventually they will be evenly distributed through the liquid, and the whole solution will be colored purple. You can dilute the solution and you can see that the color will be less purple if you add more water to the solution. Then this is called dilution, while the concentration of the potassium manganate will decrease. The movement of particles as well, or diffusion, we can view that through the diffusion of ammonia and hydrogen chloride through air. If you get a glass tube which is closed on at both ends, and then on one side you add a cotton wool soaked in aqueous ammonia, and on the other side you add a cotton wool soaked in hydrochloric acid, the cotton wool that's soaked in aqueous ammonia will be a source of ammonia gas, and the ammonia gas will start to diffuse from one end to the other, while the other cotton wool, which is soaked in hydrochloric acid, will be a source of hydrochloric acid gas, and the gas will start to diffuse through the tube as well from that end to the other. These two will start diffusing until they meet at a certain point where you can find a ring of ammonium chloride to be formed when the two gases meet each other, as they will react to form ammonium chloride. The ammonium chloride that has been formed will not be in the center of the tube, but it will be more closer to the hydrochloric acid. This is because the ammonia particles are lighter and they are faster to move and diffuse through the air than the hydrochloric acid, so they travel longer distance than hydrochloric acid and they meet nearer to the cotton wool soaked in hydrochloric acid. This is all due to the random motion of the particles and their diffusion through air. We can also see or demonstrate the diffusion of gases through each other if we do this experiment where we can see the diffusion of bromine gas through and air. So if you get two glass tubes and they are inverted on top of each other, and one of them is full of bromine and the bottom one is full of air, in between them there is a glass plate that prevent their mixing, and then when you remove the glass plate you will notice that the bromine gas will slowly diffuse through the air, and if you leave it a little bit more you will find that the bromine gas have diffused completely through the air, where the whole two glass tubes attached to each other will have the exact same color and distribution of the bromine and air.